Today, we're going to dive into a programming fundamental, regular expressions. Regular expressions, commonly known as RegEx, are a powerful tool to find patterns and text. They are basically the equivalent of using Control F on a Word document, except they're much more precise and powerful. This can come in handy while editing code, verifying a user input, or scraping the web. The list really goes on. A regular expression is a sequence of characters that define a search pattern. For example, we have this code here, which could result unintelligible for someone who doesn't know regular expressions, but this presentation is about that precisely, to get to know this regular expression. So this pattern defines any 5-letter string starting with a letter A and ending with an F. So let us see some examples. We have our expression and several strings, and we are going to test if these strings yield a match or not. The first example, the string ABS, yields no match because it is not a 5-letter string or 5-character string. It begins with an A and it ends with an S, but it's only 3 characters long. The second example, the word alias, does yield a match because it complies with all the conditions in the regular expression. It begins with an A, it ends with an S, and it is 5 characters long. Same case for the word abyss, but then we have the same word as before, the word alias, but this time written with a capital A, with an uppercase letter A. And in this case, we see that the pattern didn't find a match. And this is because regular expressions are case sensitive. So since here we have a capital A, it would yield no match. And finally, we have this another string, and it doesn't yield a match. Speaking in particular about Python, Python has a module named RE to work with regular expressions. And here is an example. First, we have to import the module, and we can define a couple of variables for the pattern and for the string we are going to be testing. And here we have this function, the function re.match. The parameters are the pattern, the regular expression pattern, and the string we are going to be testing. We can do it as in this example, previously defining the variables, or we could write them directly within the parentheses. We build an if statement, and if the function finds a match, then we will print search successful. In case this function could not find a match, then the result would be search unsuccessful, or whatever we stipulate here. And to define a pattern, to specify a pattern using regular expressions, we use meta characters. In the example we previously reviewed, we used this little hat, which is known as caret, and the $sign. These are examples of meta characters, and here is a list of various commonly used meta characters. For example, square brackets, period, caret, dollar sign, star, plus sign, question mark, braces, parentheses, backslash, and this vertical bar, uh, sometimes known as well as type. Square brackets. The square brackets specify a set of characters you wish to match. So for example, we have this expression within square brackets ABC and several strings. Number one, just the letter A, and it would yield a match because the letter A is within the square bracket. Then we have AC. It would also yield two matches in this case because both the letter A and the letter C are included within the square bracket. Number three, the string hey youth would yield no match because none of the letters within this string are contained in the expression within the square bracket. And finally, we have this string, which would yield a total of 5 matches, one for the A, one for the B, one for the C, another C, and another A, resulting in a total of 5 matches. Important to know, we can also use this dash or minus sign to specify a range of characters. For example, if we type A dash E is the same as the sequence A, B, C, D, E. Or if we type 1 dash 4, it would yield the sequence of numbers from 1 to 4. In this case, with numbers, with digits, we have, for example, this case 0-39. It wouldn't be interpreted as the sequence from numbers from 0 until 39. Rather, it would yield the sequence from 0 to 3 and additionally the number 9. There is also the chance to get the complement or the invert of a sequence or the characters that defined within the square bracket. When we use the caret, it means all the characters within the square bracket. It means all the characters except the characters within the square bracket. So for example, we have the sequence ABC preceded by the caret. It means any character except A, B, or C. And same for the numbers. If we use caret 0 to 9, it means no digit character because all the digits are contained within this sequence from 0 to 9. And if we use the caret, it means every character except for those numbers, for the numbers from 0 to 9. The period matches any single character with one exception. This backslash n refers to a break line. So here we have the example. Two periods refers to a string composed or built of two single characters. So the first string, the single letter A, would yield no match because we need at least two characters. But we see here in the second example, it yields a match because we have two single characters. For the third example, we have three characters. It would yield a match because at the beginning we have two and an additional single character. And finally, we have this sequence of 4 characters. It yields 2 matches. And here we can begin to see that the matches occur uh, as, as they appear. What I mean is, in this case, the first two characters, the first two single characters that appear in the sequence are the ones that would yield the match. So we have the match for the AC and not for the CD. And here we have the first match for the AC and the second match for the DE. The caret, as we saw in the first example, is used to define a string that starts with a certain character. So the expression caret A specifies that the string must begin with this character, with this letter A. So we have matches for the first and second example, but not for the third, because this particular string begins with the letter B. No matter that it contains the letter A, but since it is not in the first position, it would yield no match. In the second example, the expression must begin with both AB in that order. So ABC would yield a match, but HCB would yield no match because the letter A is not followed by the letter B. The dollar sign, also present in our first example at the beginning of the presentation, it checks if the string ends with a certain character. So the expression a dollar sign refers to a pattern in which the string ends with that letter, with the letter A. So in case, in a single letter A, it begins and ends with an A, so we have a match. The word formula ends with an A, so we have a match. But in the case of the word cat, the letter A is not at the end, so we have no match. The star, it matches 0 or more occurrences of the pattern left to it. So it is like saying it can have or not have this pattern. So we have this example, and it states that our expression could have or not an M and an A. So in the first example, no, we have a match because since there is no occurrence of the pattern, that means a 0, we have a match. In the second, we have an appearance of that pattern, so we have one match. We have also here MA, despite we have an additional 2A, we have a match. But in the word main, we have no match because the letter A is not followed by the letter N. And finally, in the word woman, we have a match. The plus sign, similar to the previous one, but in this case, the occurrence has to be at least 1 instead of at least 0. In this case, the pattern must occur at least 1 time. So if we go through the examples, we see that in this case, the string MN would yield no match because the letter A is not included. In the case of the word man, there is a match. In the case of the word man written with 3 A's, we have a match. Same case as before, in the word main, we have no match because the letter A is not followed directly by the letter M. And in the case of woman, we have a match. The question mark symbol matches 0 or 1 occurrence. That means at least zero, and at most one occurrence of the pattern to the left. So the word MN yields a match, man yields a match. But in this case, the sequence man written with 3A yields no match because there's more than one A, more than one letter A. The word main, as in the previous cases, yields no match because it's not followed by the letter N, and woman yields a match. Braces. The braces, I would say that the previous symbols that we have just reviewed, the star, the plus sign, and the question mark, are special cases. And the braces are a general case in which we define at least how many occurrences and at most how many occurrences of the pattern are allowed to find a match. So the letter N, the first position, corresponds to the at least how many occurrences, and M is the most repetitions allowed in the pattern. So here we specify that our pattern has to have at least 2 letter A's and at most 3 letter A's. So, and they have to be together. In the first string, since we don't have at least 2 letter A's together, there is no match. But in the case of the second string, in the second part, we have this DAAT, and since they are at least 2 letter A's together, we have a match. Third example, we have first 2 letter A's together and then 3 letter A's together. We have 2 matches. And finally, we have 2 matches together. And then we have 4 matches together, and the pattern finds the first 3 of the second part and yields a match. Alternation. This vertical bar is the corresponding or the equivalent of an OR operator. So in this expression, we would read it as A or B. So if the string contains A or B, it would yield a match. So in the first example, none of A or B is present, so we have no match. But in the second, we have at least one A, and so we have a match. And in the third example, we have 3 matches because there are 2 letter A's and 1 letter B. The parentheses are used to group sub-patterns. For example, we have within parentheses A or B or C, and those have to be followed by an X and a C. That would be our match for these expressions. In the first one, we have no match because we have a space in between. They should be continuous. In the second string, we have a match because we have the letter B followed by X and C. And finally, in the third string, we have 2 matches because the first part is the letter A followed by X and C. And in the second part, we have B, X, and C at the end. The backslash. It is used to escape various characters, including all meta characters. For example, we saw that the dollar sign is a meta character, but if it is preceded by the backslash, it would try to find specifically the dollar sign followed by a letter A. So here the dollar symbol is not interpreted in a special way, rather just as it is, the dollar sign, literally. Then we have Python and RegEx. As mentioned before, Python has this module named RE, and to use it, we need to import it. We need to import the module, and the module defines several functions and constants to work with regular expressions. We have the function find all. This method returns a list of strings containing all matches. So we import the module, we define two variables, a string to be tested and the pattern. Then we use the function find all, and the result is this pattern. The backslash D refers to any digits. And the plus sign, as we saw before, it means at least one occurrence, one or more occurrences. So within this string, hello 12, hi 89, howdy 34, we have three matches, and those would be 12, 89, and 34. And we have our output here. If the pattern is not found, the function returns an empty list. The split function for method splits the strings where there is a match and returns a list of strings where the splits have occurred. Same example as before. Every time the pattern was found, the original string was splitted. So we have 12 split, then 89 split, and finally a single period. The sub function, the syntax is the pattern or the regular expression. A string we want to use as a replacement, and the string to be tested. So this method returns a string where match occurrences are replaced with the content of replaced variable. And here we have an example. This program removes all white spaces. So we have this string ABC space 12, DE space 29, 23, a break line at 45 space 6, and the pattern here looks for every white space occurring at least one time. And we are going to replace it with an empty string. So we are basically removing all the white spaces. And here we have the result. It's a continuous string without spaces, tabulations, or break lines. The search method, this one takes two arguments, the pattern and the string, and this method looks for the first location where the regular expression pattern produces a match within the string. If the search is unsuccessful, the search returns a match object. I'm sorry, if the search is successful, it would result in a match object. If not, it results none. So we have the string Python is fun, and we are going to check if Python is at the beginning of the string. We search for this \a Python and the string as a variable previously defined. We have our if statement, and we are going to see if a match is produced. Since the string begins with Python, it would result in the first print, pattern found inside the string. Finally, we have match objects. Some of the commonly used methods and attributes of match objects are group, start, and span, RE, and string. And group returns the part of the string where there is a match. The start returns the index of the start of the match substring and returns the end index of the match substring. The span returns a tuple containing a start and end index of the match bar. So the span is like the combination of the previous start and end methods. RE returns a regular expression object, and a string returns the past string. Using the R prefix before regular expressions. When the letter R, no matter if lower or uppercase, prefix is used before a regular expression, it means a raw string. For example, \n is new line, whereas R, quote unquote, \n means 2 characters, a backslash followed by an M. Backslash is used to escape various characters, including all meta characters. However, using R prefix makes backslash treat as normal character. So it's like removing its special powers. So finally, a case of regular expressions applied in finance and accounting. Commonly within ERP systems like SAP, the companies or the controlling areas are described or named with this long sequence of characters, describing, for example, if it is a branch or the business involved, and they kind of have a logical structure and sequence. But sometimes you are interested in getting all the information, all the figures for the same business, regardless of the branch or the company code, or vice versa. You are only interested in one company or any other combination. So we could use regular expressions to find, filter, and or replace string values describing the profit center nodes within the corporate hierarchy. In the book that Satin shared with us, the example provided is regarded or related to dates, because dates are an important aspect of finance, since you are interested in to know where exactly a cash flow would occur. Yep, those are one of the most important aspects within finance that could in which regular expressions could be used. And here I just offer you 3 online resources you could use to get to know more about regular expressions. For example, a cheat sheet, um, a video on YouTube, and this is a simulator where you can build and test your regular expressions. And thank you so much. I hope you have enjoyed this session.